The next one for today is the altitude of a triangle is the segment that goes from the vertex and is perpendicular to the opposite side, which means it's going to create right angles. There are, again, 3 altitudes. The one thing that you need to keep in mind for altitudes is the fact that the altitudes can be outside the triangle. So in this case, if we look at the fact that this is an obtuse triangle, A has to, when I draw the, let me just highlight all 3 of these triangles here. When I have the altitudes here, it's outside the triangle for the first one. It's outside the triangle for the last one, which means I'm essentially extending that side. But then there's always going to be one at least that is inside. You can have all of them being inside. Sometimes in a right triangle, you would have the altitude, that would be one altitude going to the hypotenuse, but then the second and the third altitude are actually the sides of the triangle, which means the point of concurrency is the actual vertex of the right triangle. And then speaking of the point of concurrency, so another point of concurrency that we're looking at is the fact that we have all 3 altitudes that are going to meet. They will always intersect, and they will intersect at the orthocenter. So again, looking at the last triangle, if I were to extend that altitude, extend that altitude, and then extend it from C, my point of concurrency would be outside the triangle. But if I look at this one on the orthocenter, G is inside the triangle. So you could have points of concurrency that are inside or outside of the triangle. So can the orthocenter go outside of the triangle? And the answer is yes. The orthocenter can, because in an acute triangle, it's going to be inside. In a right triangle, it's going to be on. It's going to be that vertex. And in this triangle, remember, it's the black triangle we're looking at. P is outside of the triangle. So find the coordinates of the orthocenter of this triangle. So first off, we need to graph the triangle. So when I graph this triangle, in order to find the orthocenter, I need to find out where 2 of those altitudes intersect. So first off, to write the equation of one of my altitudes, I'm going to write the equation of the altitude from E to DF. Perpendicular to a horizontal line is going to be a vertical line. So x equals -4. So I already got one done. Always look for, if you can do a horizontal or vertical, it's going to make it a little easier. Then I'm going to write the equation of the line of the altitude from D to FE. So D to FE, which means I need to first find the slope of EF. And when I plug those into the slope formula, using points EF. I'm going to get a slope of 1, but I don't want the slope of EF. I want the perpendicular slope of EF, which is going to be -1. And then I need to plug that in using point D. And so y equals -1x plus b. But I actually already know b because d is 0, 6, so it's going to be -1x plus 6. I now have two equations. I can use a system of equations, but this one is going to be much simpler because of the fact that I have x already equals -4. So plug in -4, and I'm going to get y equals 4 plus 6, which means y equals 10. So I have an x value of -4 and a y value of 10, which means it's going to intersect way up there. And if I extend that orange line, I can verify that that would be where my point of intersection is. We can also use these in proofs. So using this first one, given the fact that triangle ABC is isosceles, so let's start there. That's going to tell me that AB is congruent to BC, and that's going to be iso. Tells me those two sides are congruent. I then have another given that states that BD bisects angle ABC. And I'm going to put some numbers in there, 1 and 2. So that tells me angle 1 is congruent to angle 2, because when you bisect an angle, it creates two congruent angles. And then when I use my reflexive property of BD, I can say that my triangles are congruent to each other. Triangle ABD is congruent to triangle CBD by SAS, side angle side. And then in order to say altitude, I'm going to need to say right angles first. So I'm going to use first the fact that those angles down there, 3 and 4, are congruent by CPCTC. And then I'm also going to say that they are supplementary because a linear pair implies that they are supplementary. And then if two angles are congruent and sup, congruent and supplementary, then they are right angles. And then last but not least, if I have angles are right angles, and I'm going to put this up top because I ran out of room, but that means that BD is the altitude, because if we create right angles starting from that vertex, then it's going to be the altitude. So go ahead and then take a minute to look at the last proof, pause it, finish that last proof, and then you can check your answer.